Alright, welcome to this video. In this video it'll be part 2 of our inequality basics, and in this video we'll look at some inequality phrases. You see those right up here, and you can see these in various word problems, for example, so this is preparing you to be able to spot phrases and word problems that will let you know that you need to set up an inequality as opposed to an equation, which is the opposite of an inequality, and an equation is when things are set equal to one another. Again, in this video series we're looking at inequality. So these statements in a word problem will let you know that you need to write an inequality as opposed to an equation in order to solve the problem situation. Later in the video we will also look at how to solve some basic linear inequalities. Alright, so let's look at the greater than or equal to symbol here. One example, and there are more than just one, but a common one that you will see used in word problems is the phrase at least. When it says at least, it means greater than or equal to. So if it said, if you went into a job interview and you said, they asked you how much your requirements were for salary, and you said, I need to make at least 100,000. You're basically saying that 100,000 or anything above that is okay, but nothing less than that. This next one, less than or equal to, we've talked about that symbol already, but let's look at some other phrases. Obviously, if the phrase says less than or equal to, you know it's this symbol that you need to set up. If it says no more than, if it says don't exceed, if it says at most, all of those things mean less than or equal to. So it means whatever number you're talking about, that number is okay, and anything below that number would satisfy this condition. Alright, the next one, greater than. One example of that, and there are others again, but one example is in excess of, for the greater than. So this means it's got to be more than the number that you're talking about. It can't be exactly that number, and it can't be below. It's got to be in excess, over and above this whatever number you're talking about here with this inequality. Next, the less than symbol. One example of that would be must be below. So that means you can't even be to the number that you're talking about. It's got to be something below that, something less than that. It cannot be at the number or above. It must be below. Alright, let's look at some example phrases here and how we would write those inequality statements. Alright, I brought up a few example phrases here, and we're going to go through and write the inequality statements that would go with these specific cases. So let's look at this first one right here. Make sure the payment is no more than $450. Okay, so I've bolded the important words. No more than $450. So if we go up here to our list, no more than appears right there, right? Less than or equal to. Less than or equal to. So in this case, if we let X be the payment, we're going to say that our payment X should be less than or equal to $450. Alright, so this matches a situation where we are making sure the payment is no more than $450. And we could say payment less than or equal to $450, or set instead of using X we could use P to stand for payment, but it really doesn't matter what variable we use. The bottom line is the inequality would look like this to fit this statement right here, this inequality phrase. Alright, let's look at this next one. Alright, it says my speed, we're looking at this one right here, my speed did not exceed 60 miles per hour. So did not exceed is going to be up here in this area. So I listed don't exceed before, but did not exceed would still be this less than or equal to situation. So if we let our speed be S, we're going to say that S was less than, our speed was less than or equal to 60 miles per hour. So this means that we might have gone up to 60 miles per hour, but we did not go 60.5 miles an hour or 61 or 65. We didn't do that. We might have been going 55 at times. We might have been going 59 at times, maybe 60 at times, but never over 60. That's what this means. I want to go back to this one real quick too. When we say no more than $450, so that means $450 for our payment is okay. $450 and 1 penny is not okay for this statement. But $450 or $449.99, all of those are okay. Anything no more than $450. So $450 is okay, or anything below it. All right, let's go to this next one. My speed was in excess of 65 miles per hour. Hopefully you weren't in a zone that was the speed limit was anything less than 65 in this case, because this is saying that you were going over 65 miles per hour. So if we use S for speed again, we'll say S was in excess greater than, right here, in excess greater than, our speed was in excess of 65 miles per hour. So that means we weren't going 65, we weren't going 64, we weren't going 60. We were going something over 65. 66 would satisfy this. 65.1 would satisfy this, but nothing at 65 or below. So if we were going 65, we wouldn't say it this way. We wouldn't list an inequality this way. We had to be going over 65. All right, let's look at this next example. It says, my salary this year will be at least $110,000 including bonuses. So at least, here's at least right here in our list. At least is greater than or equal to. So we're going to say, if we're going to let S be our salary again, S is greater than or equal to $110,000. Alright, so that means that we are expecting to make $110,000 or something over and above that. Not anything less than $110,000 would not satisfy this situation. So $110,000 and $1 would satisfy it. $109,999.99 would not satisfy this situation. So it's got to be $110,000 or above. Alright, let's look at this last example here. So our new cell phone plan must be below $110 per month including tax. So if we let C equal our cell phone plan must be below $110. So that is going to be right here. Must be below. Less than. Okay, so let's put that. Our cell phone bill must be less than $110. Okay. So this means that $110 is too much. $109.99 would be okay. $110 would not be okay. $110 and 1 penny would not be okay. It cannot be above. It cannot be $110 or anything above that. So again, the maximum that we would be okay with our cell phone being would be, if we're talking money, since we can't have fractions of a penny, it would have to be $109.99 or anything less than that. So $105 is okay, $107 is okay, $111 is not, $110 is not, $110.50 is not okay. Alright, so in the next part of the video, I'm going to pause it here and we'll get some inequality, basic linear inequalities, and we'll work on solving those and then graphing them on a number line. So I'm going to pause here. Alright, in this part of the video we're going to work some basic inequalities and graph them on a number line in addition to solving them. So I did add this note here. When you multiply or divide by a negative when you're working out an inequality, that means you have to flip the inequality symbol over. So if it's greater than, you've got to turn it over to less than. If it's greater than or equal to, you have to turn it over to less than or equal to, and vice versa. So that's an important rule. On this first example we won't have to do that, but we will get into some of those later. Okay, so if we have the inequality x minus 4 is greater than 2. Okay, realize that really when you're working these algebraically, it's not any different. Don't let this scare you, this inequality symbol. You're going to, the same rules are basically going to apply as if this was an equal sign and you had an equation instead of an inequality. Okay, so same rules. We're going to add 4 here, add 4 to both sides. This strikes out, and we're going to get x is greater than 2 plus 4, or 6. X is greater than 6 on that one. Alright, and then when we graph that on a number line, we'll have 0 here, we'll have 6 here, and then we've got a greater than symbol, so we have an open circle. Remember from our earlier video, we've got an open circle, and we're greater than, so everything above 6. 6.00001 is okay and satisfies this inequality. 6 is not okay. 5.9999, not okay. But anything above 6 is okay and satisfies this inequality. Alright, let's look at another example here. Alright, now we've got another inequality here, and this one we will have to apply this rule when multiplying or dividing by a negative. That means you have to flip your inequality symbol. So let's get started here. Let's write this out. Negative 3x plus 2 is less than or equal to negative 7. Alright, so the first thing that we're going to do, same as if this was an equation and this was an equal sign. Same rules. We're going to subtract 2, subtract 2. This will strike out, bring everything down. We have negative 3x is less than or equal to negative 7 minus 2 is negative 9. We're going to divide by negative 3. Here's where your alarm should be going off. We're dividing by negative 3, so we have to turn this symbol over. We have to flip it over. We have to reverse it. So instead of less than or equal to, this now becomes greater than or equal to. Do not forget that. Okay, these negative 3's will cancel, and we will have x is greater than or equal to negative 9 divided by negative 3 is a positive 3. So here's our answer right here. X is greater than or equal to 3. Then let's put it on a number line. We'll draw our number line here. We should be labeling this as x here. And our 3, let's say that's about right there. Here's 0. And this is greater than or equal to, so remember that is a solid circle. Since it's greater than, it means everything from 3 and on to the right. Everything from 3 and everything in the positive direction from that. So 3 is okay. 2.99999, not okay. 3.00001 is okay. 3 exactly is okay. 4 is okay. 7 is okay. 100, 1 million, they all satisfy this inequality. Alright, let's look at another example. Alright, we have another example here. 3x minus 5 is greater than x plus 6. Okay, same rules would apply here as if this was an equation and this was an equal sign. Alright, don't let this freak you out. Alright, so the first thing that we can do, we have two choices. We can subtract an x from both sides, or we can add 5 to both sides. Remember, our goal is to get x by itself here. So I'm going to go ahead and add 5 here. That's my choice. Alright, add 5. Remember, you have to add 5 to 6. You can't add 5 to x. Alright, now bring everything down. 3x, my symbol stays the same. It's still greater than x. 6 and 5 makes 11. Okay, now I have to subtract x. That's my next step there. So this strikes out. 11 comes down. Greater than comes down. 3x minus an x, that's 2x. 3x's minus 1x gives me 2x. 3 of anything minus one of those same things gives you 2 of those things. In this case, x. So we're going to divide by 2 as our last step. So we have, that strikes out. We have x is greater than 11 over 2. And we'll just leave that as a fraction instead of making it into a decimal or an improper fraction. Alright, so here's our answer. We'll box that in, and now let's put it on a number line. So I'll do that over here. Alright, we have, label this as x, and we have 0 here, and then we have 11 over 2. That's just over 5. It's a little over 5. So we'll put 11 over 2 here on the number line. Notice we are greater than, so we have an open circle, and we're going to point our symbol this way. Alright, I want to discuss another situation here. I want you to realize, and we talked about this in the first video, but x is greater than 11 over 2 is the same thing as saying 11 over 2 is less than x. Okay, make sure you realize that. Reading this left to right, 11 over 2 is less than x, is the same thing as reading this right to left, x is greater than 11 over 2. Okay, these two statements are equivalent. It's just on one of them 11 over 2 is on the left side, on one of them 11 over 2 is on the right side. The common protocol is to put the variable on the left hand side, but if you're given this in some way, don't let this freak you out. It's okay. Most teachers and most situations, if you end with it this way, let's say you got your x by itself on the right side and you ended like this, the proper thing to do is go ahead and just write x is greater than 11 over 2 so you get your variable on the left side. But do not, this is not equal. If you ended with this right here and then you went x less than 11 over 2, no, that's not right. That is not right. Okay, make sure that if the little side, let me say it this way, if the big side is pointing at x here, the big side needs to point at x here. These two statements are now not equivalent, so don't do that. Okay? Alright, let's move on to, I think I've got one more example for us here. Alright, last example here. We have 3 times the quantity x plus 2 is greater than 7x minus 10. Remember, just like when we're solving an equation, our goal is to get x by itself here. So the first thing that we need to do, I'm going to go ahead and rewrite this. 3 times the quantity x plus 2 is greater than 7x minus 10. Alright, the first thing that we have to do is distribute this 3 inside the parentheses. So we're going to draw our arrows here. 3 times x and then 3 times 2. So let's do that. 3 times x is 3x. 3 times 2 is plus 6. So now we have 3x plus 6 is greater than 7x minus 10. So we need to see what value of x makes this true. That's all we're doing. Alright, in this situation, just so I can show you that it's okay to end with x on the right side and how you would handle that, I'm going to choose to get my numbers over here on the left side and get all my x's over here on the right side. Another advantage to that is when I subtract 3x from this side and I subtract it from 7 over here, I will end with a positive x value. So, and I think I'll work this problem twice so you can see both methods. Alright, so let's do that. It's okay to subtract 3x first. You don't have to subtract the numbers first, or get the numbers over on one side first. This is not wrong. So I have 6 is greater than 7x minus 3x is 4x minus 10. Then I'm going to add 10 to both sides. And I get 16 is greater than 4x. Last step, divide by 4 on both sides, and I get 4 is greater than x, which is the same thing. I'm going to come over here because I'm running out of room on the screen here. 4 is greater than x is the same thing as x is less than 4. Okay? That is the proper solution. X is less than 4. 4 is greater than x is the same thing as x is less than 4. Notice when my variable was on the right, the little bitty side was pointing at x. When I rearrange it with my variable on the left, the little bitty side is still pointing at x. So these two statements I can say are equivalent. Alright, so okay, now I'm going to graph this on a number line. So we would have we'll put 0 right here, we'll put 4 right here, and then we'll be going back this way for our x here. Number lines go forever in both directions as far as that goes. We can put arrows there, that's fine. So where x is less than 4, so I'm going to put an open circle, less than gets an open circle, and I'm going to point my arrow this way because this means that 4 is not okay, 4.0001 is not okay, but 3.99999 is. 3.9 is okay, 3 is okay, 2 is okay, 0 is okay, -4 is okay. Anything below or less than 4 on the number line would satisfy this, which would in turn satisfy this original statement. Any x less than 4 would make 3 times the quantity x plus 2 be greater than 7x minus 10. Make sure that you understand that. Alright, I'm going to pause it here and I'm going to work this another way just so I can show you that it's okay to, it doesn't really matter which side or how you move your x's and numbers around. Okay, I'm going to show you another way to work this. So I'll pause it here. Alright, so now I'm back here. We still have 3 times the quantity x plus 2 is greater than 7x minus 10, so I'm going to pick it up there. We have 3x plus 6 greater than 7x minus 10. Same as before. But now I'm going to move my x's over here to this side. Okay? So I'm going to go ahead and subtract. I'll go ahead and subtract 6 from both sides. I'll do that first. It wouldn't have been wrong to subtract 7x from both sides first. That would have still been okay too. So I have 3x is greater than 7x. Negative 10 minus 16 is a negative 16. I'm going to subtract 7x now. Remember, my goal is to get x by itself. So I need all the x's on one side. So 3x minus 7x is a negative 4x. So negative 4x is greater than, notice I subtracted 7, so I don't turn my inequality over. It's only when you multiply or divide. Subtracting, adding negatives, that doesn't matter. It's only when you multiply or divide a negative. Multiplying or dividing a positive number doesn't change anything. Alright, so we have, this strikes out, so we have negative 4x is greater than negative 16. Now, I'm going to divide by a negative, so I have to turn my inequality over. Alright, so this turns over now. So I'm going to have x is less than, negative 16 divided by negative 4 is 4. So I have x is less than 4. So that's the same thing that I ended with before. The same answer, it's just now I ended with my x being on the left side. So I just want to show you that. You had two ways to work it. The other way I ended with x on the right side. That's not wrong, and then I just rewrote it. In this case, I left my, I worked it so that I ended with x on the left side again. Okay, so there's my answer both ways. Let's go ahead and put the number line on here. So, alright, so we had 4 here, we have 0 here, and where x is less than 4, less than gets an open circle, and we'll point our arrow that way. Alright, this concludes that video. Make sure you subscribe on YouTube, post comments, ask questions. I'm here to help. Talk to you later.